Okay, in this video I'm going to talk about the segments connecting the midpoints of the opposite sides of a quadrilateral, of any quadrilateral, and the fact that they intersect and their midpoints. So basically we have an arbitrary quadrilateral. We take the midpoints of its sides. And we connect the midpoints of the opposite side. So this segment and this segment. So we consider these two segments and their intersection points, And the theorem basically states that this intersection points divides like each of these segments in half. So like basically that this segment is equal to this segment, and that I don't know how to denote it, like let's say something like this. So this segment is equal to this segment, and this segment is equal to this segment. So this intersection points, it divides each of these segments in half, which is kind of a curious fact. So let's denote the vertices CD, MN, K, L, and the intersection point would be let's say it's P. So this point is P. And so the theorem is that MP is equal to PK and NP is equal to PL. Yeah, so basically there are two proofs, like I'm going to show two proofs. So the first proof is just a simple corollary of the previous of the statement that I proved in the previous video. So there I proved that the quadrilateral formed by these midpoints, so MN, KL, it's a parallelogram. So from the previous video, right? So the quadrilateral MNKL is a parallelogram. This it's from the previous video. Like we can say that it's a known theorem. And from this, this statement immediately follows, because in a parallelogram, like it's a in a parallelogram, it's a well-known fact that the diagonals intersect. Like diagonals are divided by their intersection point into equal halves, right? So this can be proven simply by considering the equal triangle. So this triangle would be equal to this triangle, because it's a parallelogram, so the sides are parallel. So this angle, this angle is equal to this angle, this angle is equal to this angle, and this angle is equal to this angle. So all three angles in these triangles are equal to each other, and also the opposite sides in a parallelogram are equal. So therefore these triangles, these two triangles are equal to each other, therefore the diagonals are divided in half by the intersection point. So yeah, so MNKL is a parallelogram. From this it follows basically that MP is equal to PK and NP is equal to PL, and this concludes the proof. So the second proof is more curious, more interesting, I would say. So we have our quadrilateral, and basically the proof uses the masses. So I showed, like, I have a video like about how to use the masses in geometry, that we can prove using the masses, that I think I proved that the medians in the triangle intersect in the same point, like in a single point. So here, so let's put masses 1 in each vertex of the quadrilateral, right? So, and we are going to search for the center of mass of these 4 points. So, and like calculating it in 2 different ways, we will obtain the result. So first, we group the masses this way. So these 2 masses together and these 2 masses together. So the center of mass of these 2 masses, of course, is the midpoint, right? So like it's equivalent to replace these 2 masses of size 1 to 1 mass of size 2 here in the midpoint, because like we can replace a set of masses with the mass of the sum at their center of mass, right? So, and these 2 we replace with a single mass of 2 at this point. So the center of mass of the original system is equivalent to the center of mass of these 2 masses of size 2 at these midpoints. And the center of mass of these 2 is, of course, the middle of this segment. So if we recall the notation, so this is point M, this is point K, and this is, so the P was denoted as the intersection point, so we don't have it here, but the center of mass, so the center of mass, is the midpoint of MK, the midpoint of MK. So like these 2 masses we can replace now with a single mass of size 4 at this midpoint. So now on the other hand, if we return to the original masses and group them some other way, so we have these 2 original masses of size 1, and we group them like this, these 2 together and these 2 together. Then the center of mass of these 2 would be at point N, and we replace these two masses of size 1 with a single mass of size 2 at point N. And similarly for these two, we replace them with the single mass of size 2 at point L. So the center mass of this 2 would be the point L. And then we have the segment. Let's remove this segment. So then we have the segment NL, and the center mass of the points N and L with the size 2 would be the middle of the midpoint of, so the center of mass now center of mass is the midpoint of NL, the midpoint of NL. So we can replace now these two masses of size 2 with the single mass of size 4 here at the midpoint of NL. So, but any system of masses has only one center of mass, right? Regardless how we group them initially, like the center of mass must be the same. So these two, like this center of mass that we found here, should be the same as this center of mass that we found here. It should be the same. Therefore, the midpoint. So from this we conclude that the midpoint of MK is the same point as the midpoint of NL, right? So the midpoint of NL is the same point as the midpoint of MK. Therefore, this is the intersection point. Therefore, these both midpoints coincide with the intersection point of. So from this it follows that since this common point lies on both NL and MK, therefore this is the intersection point. So both of these midpoints of MK and of NL coincide with the intersection point P of MK and NL. Yeah, and this concludes the proof. Therefore, I can write even more explicitly. Therefore, P. Therefore, MP divides each of these segments in half. So MP is equal to PK. Therefore, P is the midpoint of the midpoints of both of these segments. So MP is equal to PK and NP is equal to PL. And this concludes the proof. Yeah. So using masses in geometry can be powerful because of the different groupings of masses and the fact that no matter how we group, the center of mass is unique. This allows to prove some statements in geometry. yeah, so that's it for this video.